Hey, what's going on, fellas? We're back here with the Crucible free foundry one more time, and today's experiment is to determine how hot we can get this thing with a 6.5 horsepower air compressor. This is 120 kilowatts worth of burner power right here. You're looking at 12 liters an hour. That's about 3.1 gallons per hour. So if you're running agricultural diesel, it's about $6 an hour to run this thing. On waste oil, it's pretty much free. We're at about 42 psi's back pressure, and we're going to see what this thing can do today. Unfortunately, this air compressor isn't totally adequate, but it does do the job. So we're going to be seeing how hot this thing gets. Every half hour we're going to look inside of it. We've just fired it up. You can see things are not really hot inside of there yet. Beautiful cyclone combustion configuration going on inside of there. We're basically turning this thing into a jet engine. The fuel pump we have here is a very special type of fuel pump, a roller bearing pump, and that's the power supply. We have a 50 mesh oil filter and a fuel tank ready to roll here with 5 gallons of fuel in it. And I want to show you guys something really cool here. You can control the flame using this PWM. And it's a lot better than using the valves. You can fine tune the flame. So when you're smelting copper, you want to start off with a high oxidizing flame to burn out all the impurities, and then you can switch over to a reducing flame, or like this here. So very cool that you can control the throttle with this PWM. Can control the oxygen input in some sense like that. So I definitely think that's awesome. So a half hour in, we're hitting 2,174 degrees was the max temperature. The flames kind of get in the way of the IR gun. The IR gun can't see through flames. So here we are coming up on an hour, and we are above the melting point of cast iron. Very hot inside of there. The door isn't glowing yet. I think we're getting a lot of air sucking in through that door. Maybe I should put some gaskets on it. Alright guys, 90 minutes in, and it's so hot it catches my gloves on fire when I open the door. 2,484 degrees is the max temp. We're well above the melting point of cast iron here. Unfortunately, I noticed that my air dryer is completely saturated. I didn't start off with a fresh charge, so we're going to go ahead and shut down. Okay, so despite the fact we had an inadequate air supply to run these 3 burners, we still achieved a temperature of 2,484 degrees Fahrenheit, which is approaching the temperatures needed to melt steel. Cast iron melts in the 2,100 to 2,200 degree range. So for the people asking me if this thing can smelt cast iron, indeed it can. And from the size of this bowl, when I did the calculations of the design dimensions, I was shooting for a 75-pound pour for the maximum, because anything bigger than that, it's hard for a person to carry the ingot. We're going to be pouring anodes with this most likely. That was the initial plan. We may just be going to a strategy where we pour shot. Instead of casting anodes, we pour shot that is then placed in anode cages made of 3/16 stainless steel for the purification process. This entire foundry is built for the purpose of metal purification.